Okay, so I came home with this free microwave that I found on Facebook Marketplace, and my wife's like, "Now what did you bring home?" So anyway, I wanted to show some of the useful things parts that are in a microwave. This one just had the fuse blown and would have worked, but it's one of those kind of large microwaves that goes over the stove and has a vent system in it. But anyway, I wanted to show a little bit about this microwave. I removed this control panel, which has all the controls for the microwave, and in this particular one, it even has the whole little wiring diagram and little manual thing that came with it. And so it shows all of the wiring. And the one thing you want to be careful of in a microwave is the magnetron. And that's the part that actually produces microwaves. And so you don't want to, power that on. So that's one thing that, without proper shielding and proper knowledge, you would want to leave alone. I know something about them, so I pull the magnets out of them, but you have to be careful because the ceramic portion of the magnetron can be dangerous if you scratch it or break it or create any dust that you can breathe. So if you're not familiar with them, then it's best just to leave that part alone. So what I wanted to do is show a little bit about some things that can be done with some of the parts in a microwave. Like I said, this one was a over the stove vent microwave, so it has a heavy duty vent fan and some additional things that maybe not all microwaves have. But what I want to start with anyway is the control part of it. And there's a main relay in this particular one that just has a little connector and a couple of wires coming off of it, so it makes it easy to control things with the timer that's built into the microwave. And this one has a transformer, so it can accept 120 volt AC power right into the control panel. So what I found out from that wiring diagram is that this blue and gray wire is your neutral and the black wire is your hot. And so I have a fuse. This was initially it was a 20 amp fuse inside here, and that was blown, and I replaced it with a 2 amp fuse, or 2.5 amp fuse actually. Which is plenty because I'm not powering the whole transformer and magnetron and everything. So that's just for safety, in case something gets shorted or whatever. So in this case, if I plug this in to power, then it gives me power to my the control panel, and you can set the time if you want, but every time you unplug it, it loses the time. There's no battery to keep track of the time, so I just don't bother with it. I just hit the cancel button and it goes to 1 o'clock. So if you want to set the cook time, you just hit the cook time, and you can put 10 seconds in and hit start, and it would, as soon as it gets to here, it closes that relay, and starts counting down the 10 seconds and then sets off the little buzzer when it gets down to 0. So that's the part of the timer that we're going to be using. So I'll disconnect my AC power, and so I have these little terminals that I can connect different things to power up. And you can power, since it's just a set of relay contacts, you can power things that are either an AC load or even a DC load just through the direct contacts. So my power comes in here, and then this goes to one of the contacts. This white wire goes to one of the contacts of the relay, and this is the other contact of the relay. This particular squirrel cage fan, we're going to test that out. So I have the neutral wire connected to my neutral bus, and then I'm going to connect the black wire for the fan to the other side of the relay. So now I can plug my AC power back in, and then I can set my cook time, and let's just set it to 20 seconds and hit start. And as soon as it starts this fan in high speed mode. The black wire is high speed and the white wire is low speed. And it's at 5 seconds now. As soon as it counts down to 0, then it'll shut off. So there you go. You have a timer that can control an AC load. I'm going to disconnect my AC again. Every time I do any wiring changes, I want to make sure that AC is disconnected so I don't have any chance of shock. And I'm going to pull that neutral wire out also. So right now I just disconnected this fan. Also, I should mention this fan has needs a capacitor for the motor to run, and so if you take something like this out of the microwave, you need to keep that capacitor in the circuit for this type of motor to run. And capacitors you want to be careful of because they can store charge. In many cases, they'll have a bleed down resistor that gets rid of the charge, but not in all cases. So you want to be wary of that, and aware of that, I should say. And so this is the motor that's used to run the turntable in the bottom of the microwave, and so I'm just going to connect that up. And this is a 120 volt motor. This is a synchronous motor, so normally they don't have much of a startup torque, much torque for startup torque, but in this case it's geared way down. You can tell when you turn it, it has a lot of gears in there, and so it does have a little more torque and a little more power, but this one's set up for 6 RPMs, so it'll turn 6 times in a minute. So let's go ahead and connect our AC again, and we can put in a start time of well, let's just do 10 seconds again and hit start. So as soon as it starts, right there you can see it's going clockwise in this case, with this particular synchronous motor, each time you start it, it randomly starts either clockwise or counterclockwise. That's why many times you'll see the turntable turn either clockwise or counterclockwise depending on how it starts. So let's just do another 10-second run and see if it still goes clockwise or counterclockwise. See there, in that case it's going counterclockwise. So there we get a synchronous motor out of the microwave. I'm going to unplug AC again, and here's another fan that came in the microwave. In this case, it's a shaded pull motor with a fan. Let's hook that up. And this fan has actually the European color codes. So blue is neutral for European and brown is hot in the European country code. You'll see that on their power cords also. This is an American power cord, so as neutral's white, hot is black, and ground is green. A European power cord has blue as the neutral, brown as the hot, and then it's a green-yellow wire, what they call PE or protection earth. We refer to it as ground. Okay, so let's plug this back in. Now we should be able to control this fan. So we'll hit cook time, and let's just set it for 8 seconds. Let's hit the start button, and as soon as it starts up the fan, you guys able to see that? And there it started and turned it off. So there's another fan, shaded pull motor fan that we get. And now I'll quickly demonstrate how to connect up a DC load. So I'm disconnected. I'm unplugged from AC power, so we're safe to be doing things. And I'll disconnect this wire from the hot bus, and we'll disconnect that fan from the neutral bus. So now we just have our two relay contacts. So got a battery here, so let's do this. Let's look. Get a red wire to the positive terminal of the battery, and we find a DC load. So here's a 12-volt DC load. We'll connect the battery to there. I'll show you what it looks like lit up by just touching to the battery. It's just a red glowing light. So I'll just connect that there, and I need one more lead. Oh, here it is. Okay. make this connection back to the negative side of the battery. Okay, so now we'll plug our power back in. Reset that. I need to put the light where you can see it. And cook time, and just set it for 20 seconds. Hit the start. And this red light should come on. It's counting down. It was set for 20 seconds, now it's down to 9, 8, 7, 6, 5, 4, 3, 2, 1, off. So there you go. We got an electronic timer that can control either AC or DC loads, and we have all these fans and motors. We have light bulbs in this case. It came with 3 of these light bulbs. You get switches that are normally open and normally closed contact switches that come in the door handle, the safety circuit, and you get thermal switches that are closed until they heat up but hot enough to open. So lots of parts. There are other parts. There's a transformer that can be turned into a battery charger or even a battery spot welder by just redoing one of the windings in the transformer. And what I did with all the sheet metal and that stuff, I ripped all the welds, the spot welds, with using just a crowbar, and then I was able to fold the metal into flat sheets and compact it pretty much so that it could just easily be either tossed or recycled. So there you go. It's not as bad as my wife thought. And there's a lot of useful stuff and good things that you can use to build things. Alright, so please, if you like my video, please give it a like and subscribe and share my videos. Thank you very much.